All right, so 8.3, day 2, looking at examples 3, 4, and 5. Not that much new here. Really specifically, we're talking about minimum and maximum. We touched on that at the very end of yesterday, just because you had one question on the homework on it. Tell the person next to you, remind them, what do we know about minimum or maximum? All right, so I heard some people talking about it. Well, we should be able to tell if it has a minimum or a maximum straight from the equation. Right? Talk to the person next to you about that equation. Is that going to have a minimum or maximum and why?
I think
All right. Here, raise your hand. Tell me, what do you think? Here. What do you think, Eli? Okay, why maximum? Yeah, so because that's a negative, right? Because that's a negative, we know the graph is going to open down. And if it opens down, there's going to be a maximum value there. So anytime A is negative, that means it is going to be a maximum. If A is positive, there's going to be a minimum because it's going to open up. So we have a lowest value. So we should know that again, just by looking at the equation. And that's part of what they're going to ask you on the questions today. They're going to say, is this a minimum or maximum value? But then they're also going to say, find the value. That minimum or maximum value, what is that? What is the minimum or maximum value that we're looking for, right? We're looking for the vertex, and more specifically, what part of the vertex? The x? Not the x, the y. Y. The x is your side to side, right? Your x value, that's the a of x. The minimum or maximum is how far up or down it's going. So that minimum or maximum value, okay, those are the y value of the vertex. That's the y value of the vertex. So if they're asking us to find that value, they want us to find that maximum in this case, then we need to find the vertex. We need to find the a of s first, negative b over 2a. We need to plug that in, and then whatever we get out after we plug it in, that's our maximum value. Okay, I want you to go ahead and do that for this problem. Find your a of s, your negative b over 2a, then plug it back in to get your maximum. Okay, so as you're going through and solving that, remember you can solve it on paper, right? You can solve it step by step like I just did. You can use a calculator for the whole thing, right? If you want, you can type this entire thing right into the calculator and it's going to do all the work for you at the same time. As long as you type it in correctly, as long as you put that -3 in parentheses, then you're good. And you should be able to get that out. Okay? If you want to do it in your head, do it in your head. That's fine. As long as you get the right answer. If you're not getting the right answer, then stop doing it in your head. Okay? All right, so we have 17 for that maximum value. Any questions on that? Okay. That's a few of the questions you're going to see today are going to just look like that, right? Minimum or maximum, and what is that value? But then we're going to run into some word problems as well. So here we are looking at the Mackinac Bridge. The artist rendering anyway, not actually the bridge. But I assume that the data from this, the actual numbers are correct. All right, so we've got the equation, which is a crazy equation with lots of decimals and zeros in there. So that's why I assume that it's correct. And we want to know what's the height of the cable above the water at its lowest point. So that's this red parabola. That's the cable. We want to know what's the lowest it goes here. Okay, what's the lowest it goes? What's another way of asking that question? Besides what's the lowest that it goes? What's the minimum, right? That's what they're asking. Okay, talk to somebody, work it out together. Okay, you got decimals, you're gonna have to use calculator for sure. Okay.
And then it's divided by oh. Yeah, I don't think I did. Okay, so wait.
Yes.
Oh. Because it's divided. Did that? It doesn't seem like it's a foul, you know, because not even the small thing. Oh, yeah. So that would be the extra. Make that. Or just do 7.72. So it's not the rest of it, and then the second.
6.
And then minus.
Let's run our answer to the nearest foot.
Oh, to the nearest foot. Okay, so it's 2.
For your answer, round the answer to the nearest foot.
400.
let's talk about it here. So you find your A of S, your A of S is gonna be here, right? Which we can double check, make sure that makes sense. Just under 1900 is gonna be about right here. That looks like it's the bottom point, right? That's where that bottom point should be, is right around there. Now, the more digits you keep of this, the more accurate, the more exact your numbers are going to be, your answers are going to be. The more you round during your problem, the further away your answer might get from the actual answer. Okay, so we got to be careful there. That being said, right, if you round it to like 0.76 or even 0.8 or even 1888, I believe we end up with the same thing to the nearest foot. So depending on what you rounded to, you just have to be ready to use that in your next step. And your next step is to plug that in for X here and here. Use the calculator. Again, type that all into the calculator at one time. Let it do all the work together. Raise your hand. What did you get for an answer here? Ava? 203 feet. Which we should be able to look at our picture and it should make sense, right? If this is 500, this is 250, and it's a little bit lower than that. So 203 feet makes sense when we look at the picture. And if you didn't get 203 feet, chances are you typed something in incorrectly into your calculator. All right, questions on that? Okay, last sort of thing that we got to talk about is you're going to see questions that ask you more than just the minimum or maximum. So let's say it's a problem about, there's one in the book about a horse jumping over a fence. Okay, a horse jumping over a fence. And surprisingly, the horse jumps in a parabola shape. It's crazy, right? So here's that horse jumping. And so it's going to ask you multiple parts of the question. And one question that we haven't really mentioned is, how long will it take before the horse gets to a maximum height? How are we going to figure that out? How long into this jump, or how far into the, or I don't want to say long, or how many seconds into the jump will the horse be at its maximum height? What are we finding there? Either the maximum is going to be how tall the horse goes, or how high off the ground the horse goes. How long it takes, or how am I going to find how long it takes? James?
You gotta find the axis of symmetry.
Yeah, I got to find the A of S, because the A of S is where that horse is the tallest, right? That vertex. So if we want to know how many seconds it takes to get to that max height, that's your A of X. Okay, that's that middle value. Let's say we solve it out and it ends up being 1. 1 second into this horse's jump, it is the highest possible. Okay, then we can find how tall the horse went by plugging that back in and getting that maximum value. The other type of question might say, how long was the horse in the air? Raise your hand. How long was the horse in the air in this situation?
2 seconds.
2 seconds. If it takes 1 second to get to the highest, which is the middle, it takes another 1 second to get to the other side. So we just take that A of S, we double it. The horse was in the air for 2 seconds. Okay, so you're going to see a question or two that asks that sequence of questioning. Really, all you're doing today, guys, all you're ever doing today is you're finding the A of S and you're finding the vertex. That's going to answer all your questions. You just got to realize where those numbers go. Okay. Any questions about it? All right, go ahead.